In the last video, I have explained to you about magnetic force. Now, how can we get the direction of magnetic force? We know that a moving charge in a magnetic field will experience some force, and that is nothing but magnetic force. Now, what will be the direction of it? That can be measured with Fleming's left-hand rule. Now, we have three fingers which are mutually perpendicular to each other. Perpendicular, perpendicular, and even these two are perpendicular. Okay, this is thumb, index finger and middle finger. Now, middle finger will represent direction of positive charge. Very important. If electrons are moving in this direction, then you have to take it as in this direction. So, basically, this one is direction of current. Okay, so if electrons moving in this direction, you have to take opposite as the direction of current. So, direction of current is middle finger, pointing finger is direction of magnetic field, and thumb represents the direction of force. Now, here the magnetic field is in this direction, into the plane. Now, Q, let's say this is positive charge. So, current is going in this direction. When positive charges move in this direction, that is nothing but current going in this direction. Now, what is the direction of force? Force is represented by thumb. So, it will have a lift in this direction. But, now, what will happen to the velocity? Let's say the velocity is in this direction. Okay. Now, only there will be change in velocity when the force is along the direction of velocity of, or if at all if there are some force in this direction. Now this can be split into one along this direction and one perpendicular to this direction, right? Now this here the force is completely perpendicular to the direction of velocity. Now this kind of force can never work on this velocity to change its magnitude. The velocity magnitude cannot be changed here. If let's say if force is in this direction, if velocity is in this direction, it will accelerate, velocity will increase. Let's say I have a force in this direction. So this force can be split into two directions. One is F cos theta and another one is F sin theta. Now the moment I split into two rectangular component, I can avoid this force. Now, F cos theta can increase the charge's velocity and F sin theta cannot work on magnitude of velocity. So, anyway, in this case, these are not applicable. It is neither in the direction of charge or not on an inclined direction. It is exactly perpendicular. So, this perpendicular force can never work on the force to change its, work on the velocity to change its magnitude. So, what it can do, it can change its direction. So, the charges moving in this direction now will become in this direction. Now, when they are moving in this direction, again the force will change to this direction. How will the force change? You can apply Fleming's left-hand rule. Direction, magnetic field, force. Thumb, force, direction of current, this one, and magnetic field. Now, what will happen? This will exert a force in this direction and that will now become in this direction. Again, current in this direction, magnetic field, now force will become in this direction. Now what is the property here? Here direction of force is continuously changing. Continuously. So I have made it in this way, but actually at every position this will happen. Here this will happen, small change will be there. So completely if you are taking, that will undergo a circular path. Is that clear? That moving charge, when its velocity is perpendicular to the magnetic field, what it will do? It will simply have a circular motion with a uniform speed or uniform magnitude for velocity. Velocity's magnitude will never change. What will happen? Its direction keep on changing and that will revolve in a circular path. Clear? But if a charge is placed in electric field, what will happen? The charge will experience a force. What will be the direction of force? Along the direction of charge. Along the direction of electric field. So force is equal to Q into E. The direction of force will be direction of electric field. So what will happen? That will simply accelerate. Accelerate means magnitude of velocity will change. So compare and learn. Change. So here in this case, magnitude of velocity doesn't change, but direction changes. But here in this case, it will get a direction. Now the velocity when a charge is kept in an electric field, then the force will be along the direction of electric field, and after that there won't be any change in the velocity for direction, but magnitude will keep on changing. That is, the force will now move in this direction where its magnitude of the velocity kept on increasing. Here magnitude of velocity doesn't change, but the direction keeps on changing, and that will have a circular path. Now, how to get the value of time period? Let's say this is going to repeat the motion after each and every circular path, right? So one circular path, again that is going to repeat second, third, fourth. So this is a periodic motion. Okay, now we will try to get the time period, frequency, velocity, and even radius of the circular path. Okay, so in the last lecture, I have told you the force on moving charge will be Q into V cross T, or Q V T sin theta. Okay, now here in this case, what is the sin theta? Sin theta is nothing but angle in between vector V and vector B. Now velocity, here it is in this direction and magnetic field is into the plane. So what is the angle? Into the plane, and velocity 90 degree, right? 90 degree. So this will be sin 90. What is sin 91? QVB will be the force. But how does this force has been used? It has been directed to the center of the circular path. Now how will the force be used? It will be used for the centripetal force. Now for every body to have a circular path, it should have a centripetal force. And what should be the value of centripetal force? mv square by r. Now for this body, what is this body? It's an electron having a mass of an electron. Now for this to have a revolution in this way with a velocity of v, with a radius of r, it should have a centripetal force. Who will provide the centripetal force? Now this force, this magnetic force is used as centripetal force. The centripetal force Fc is required here. That has been provided by Fp. What is that? Magnetic force. Now I will equate this with QVB. So from here I can get the value of velocity, and I can even get the value of radius. So one velocity and other velocity will be cancelled, and r will be mv by qb. Very important relation. Okay, r is equal to momentum of moving electron magnitude of momentum of moving electron divided by q into b. So this will be the radius of circular path. Now here I can also get the value of velocity. What is the velocity? Velocity is equal to QBR divided by m. You can rearrange, but here in this case we have to find the value of omega. So when it have a complete revolution, what is the total distance it has covered? 2 pi r, right? That is the circumference. So 2 pi r distance has been covered with the velocity of v. We have the velocity value here. Okay, so the total distance 2 pi r divided by the velocity, magnitude of velocity, will be giving you the time. How will you get the value of time? Time is equal to the total distance covered divided by speed. Now magnitude of velocity is the speed here. So 2 pi r divided by this one. So 2 pi into r is nothing but the radius here, divided by velocity q b r by m. So r will cancel. So what will be the value? 2 pi m divided by qb. This is the value for time period. Now if you get the value of time period, how will you get the value of frequency? Frequency is equal to 1 by time period. So the value will be qb by 2 pi m. Just inverse of this. Now how to get the value of kinetic energy? You can get the value of kinetic energy with an equation half mv square. So what is the value of v? This one. So half m into square of this one. So q square b square r square divided by m square. So m will cancel, that is q square b square r square divided by 2m. This is the kinetic energy of moving electron in a magnetic field. How to get the value of momentum? You got the value of kinetic energy, right? From this you can get the value of momentum. We know that kinetic energy is equal to half mv square. Now what is the value for momentum? Momentum is equal to mv. How can we substitute the value here? Just multiply this with m and divide with m, so that kinetic energy will become m into m square v square. So that is nothing but mv the whole square divided by 2m. What is mv? Momentum. So p square by 2m is kinetic energy. So you can substitute p square by 2m here and we'll get a new value for momentum. So p square by 2m is the kinetic energy that we have got the value q square b square r square divided by 2m. I can cancel this m and m, even 2 and 2. So now I will get the value of p square. So p is equal to q into b into r. These are very important relations. Any of the derivation, either to find v, kinetic energy, time period, frequency, radius, momentum, and kinetic energy. So any of these can be asked in your examination to find as a 3-marker derivation. Even 2 or 3 of this together as a 5-marker derivation. Thank you.